For XJ Developer to create a boundary scan test that controls your board correctly, it needs to understand which nets are power and ground. You don't want it trying to drive a pin low that's connected to a supply rail, for instance. So in this series of short videos, I'll show you how to categorize power, ground and termination voltage nets in XJ Developer. After you've loaded the information about your circuit's design as described in the series on entering board data, you need to go to the Power and Ground Nets screen, where the categorization will be done. There are 4 sections. On the left is the Net Selector, which is our starting point. It lists all the nets in your design and shows which of them XJ Developer's analysis suggests might be power, ground, or termination voltage nets. The process for categorizing the nets is to move them from this Net Selector section into the other 3, power nets here, ground nets here, and any termination voltages here. Other types of net don't need to be categorized. At the end of the process, we want it to look like this, with all the power nets categorized appropriately and non-power nets still in the Net Selector section. Let me show you how to get there. XJ Developer uses various methods to make its suggestions. One is to check all the net names to identify any that look like power, ground or termination voltages. The results of that search are shown in these first 3 groups. Let's look at those first, and I'll come to its other methods in a moment. If I expand the suggested ground nets list, you can see it identified a net in this circuit called GND. And if I expand suggested power nets, you can see it also found a collection of supply rails. XJ Developer comes with a set of default search criteria that it uses to analyse the net names. If it doesn't find your power and ground rails because the nomenclature in your design is different, you can edit the search expressions. And I'll show you how to do that in the next video in this series. The default criteria work with most circuits though, so for now let's say all the search expressions are suitable. In which case, simply use your mouse to drag the net names into the appropriate field. If you accidentally put it in the wrong place, just drag it to the correct one or back into the Net Selector area. But make sure it's only power rails you move over. This circuit has 3 sense lines that provide inputs to the ADC, and they've been picked up here because of their names. Those are not power rails, so they're going to remain uncategorized. And I should add that if you've got negative rails in your circuit, just treat them the same as positive rails and categorize them as power nets. As you can see, there were no termination voltages in this circuit. They are often used with DDR memories to provide the mid-rail supplies needed for the termination resistors. I'll talk about those in the 3rd video of this series, so be sure to watch that if you've got that type of supply rail in your circuit. So far, we've only categorized the nets that have obvious names, but a circuit may have nets that aren't named so clearly. For example, look at this circuit. This regulator's output wasn't named during schematic design, and so it's got an auto-generated one, which won't be found when the net names are analysed. Nevertheless, it is a power net, and XJ Developer needs to know about it. The software has a way to find nets like that, and that's the next step. After you've assigned all the nets that are clearly power, click this Find Links button. It's going to use the circuit data to check what's connected to those power nets you've already identified. XJ Developer will see if any of the power nets are connected to low resistance devices like ferrites, low value resistors, inductors or fuses. If they are, XJ Developer suggests that the nets on the other side of those components could also be power nets. It can do much of that using the net list, but to find low-value linking resistors, it will need BOM information, so it's important you've already imported component values. Let's see the Find Links button in action. XJ Developer checked what's connected to the categorized nets and found several ferrite beads. It's therefore suggesting that those devices are linking power nets together. If you're happy its assessment is correct, leave the ticks in the Assign column and click OK. It will now categorize those ferrites as passives. Now that XJ Developer knows for certain that those are low resistance linking devices, you can see it has added the net that wasn't labelled on the schematic. Note also how it's shown in a hierarchy. That's important because it tells you that they're linked via a device in the circuit. The impact of that is that if the linking device is later changed to unfitted, the additional net will no longer be classed as power. In case there are more nets linked to the one we just found, you now need to click Find Links again. Each time you add another power net to the list, repeat the process until it no longer finds any new devices. Do this for each of the categories that contain nets. If you ever realise you've made a mistake and a linked net has become incorrectly assigned to power or ground, you correct it by removing the categorisation of the device. You can't just drag the net as you could for one that's not linked. To remove the categorisation, you'll need to go to the Categorise Devices screen and find the device that links those nets in the list of passives. Highlight it and click Remove. If you then go back to the Power and Ground Nets tab, you'll see the linked net has now been removed from the list. It's also useful to know that at any time you can right-click on a net or device and select Show in Schematic to view it on the circuit diagram. Like here, when we want to check if a suggested net is actually power, or here to check the function of a potential linking device. Once you're happy that all the linked power nets have been found, there are two final sections you should check. They're the Suggested by Components and Suggested by Capacitor Count groups. Those are collections of nets that XJ Developer suspects could be power or ground based on the type and quantity of components connected to them. In this section here, XJ Developer has listed nets that have multiple capacitors connected to them and could therefore be power or ground. Of course, it could also be something like a sensitive RF control line, so check them carefully before categorising them. Here again, the ability to view them on the schematic can be helpful. Once you've been through the suggested lists and are happy that no power or ground nets have been missed, the net categorisation process is complete. Before going on though, I strongly recommend you check your categorised lists to ensure it's only power and ground nets that have been included. In particular, watch out for digital signals like 3v3 enable or 3v3 power good, or nets like those sense inputs we looked at earlier, all of which can easily be categorised by mistake. After those final checks, you can be happy all your power and ground nets have been categorised. In the next video in this series, I'll go back to look at how to change the text that XJ Developer looks for when it searches your net names. And in the final one, I'll talk more about categorising termination voltage nets. Thank you for watching this video. If you found it helpful, please subscribe for more and leave a like or a comment below.